So Wednesday, this coming Wednesday, there's no class, so do not come to school. There's no school for this coming Wednesday. It's Thanksgiving. This coming Monday, it is last day to withdraw. So what does that mean here is that if you are not doing well in my class, in mostly all North Hennepin classes, if you scared that it might affect your GPA, then this coming Monday will be your last day to withdraw from any classes. You can either withdraw it from the register, or you can withdraw it via online. I think in using the D2L, I think so. So, but you can withdraw it so that it won't affect your GPA. You won't. I mean, it's just a W in your transcript instead of a D or an F. But you need to talk to your advisor regarding with your financial aid, because if you withdraw your class with financial aid, you might be in probation or some other stuff. So talk to your advisor first before you withdraw any classes. So those are the two main things here. Anyone have any questions here?
Okay, so are you able to, like, can I go back and refix that thing? Because I did it to the extent that I got very frustrated. I didn't I don't know.
Nafisa, talk to me after class. Yep.
Okay.
Yep, talk to me after class. Now, we're going to talk about 9.2, your online homework, and then after that, we'll talk about 9.3, because we are going to go through 9.3 today. So 9.2 is due this coming Wednesday, and as you know that we are not meeting this Wednesday, so we will talk about 9.2 here. So we're going to talk about question number 8. Tevan asking me that questions. Now, class, if you send me an email asking me questions, please check the email, because I will reply. I did reply back. So this question is asking us to find the data of the IQ score between two blood level. One is using the medium LAT, and one is a high LAT level. And so we assume that the two samples are independent from the simple random sample from normal distributed populations, and we also assume the populations are equal. So this assumption that you see here is just to not go over your requirements. Okay, so you need to do this question. Is asking us that you need to test the claim that the medium lead is higher than the subject with high lead. So that means medium is higher. So we say that the first population is medium and the second population is high. So which one is the correct hypothesis statements in this case? A, B, C, or D in this case? You want to test that medium lead is higher than the high lead level. A, B, C, or D?
B.
D as
B.
Okay, right. So this is correct. So B here, because your now is always equals and we want a higher, so it's greater than. So this is the correct hypothesis statement here. And next, they want you to do your test statistic. Now, if you look at the data here, one gives us the mean, the standard deviation, and the sample size. The other one is given us the data set. So you need to transform this data set into your N1, X1 bar, and S1. So Tavern, this is what I did reply back to you. So you have to import this into your StatCrunch and figure out what is your N1, what is your X1 bar, and S1 means you go back to your chapter 3 where I give you the mean, the destination, and the method that you guys did in your midterm. So you go to calculators, summary stats, sorry, go to summary stats and you go to some columns, you push the var1 and you hit compute. So this is the mean and the standard deviation we have. So, and the n is given here. So you have to use this to find your your test statistics for this question. So N1 in this case will be 11. Your X1 in this case, you cannot round, so make sure you use all those digits. 89.72, this is X1 bar, 7273. And then your SX, which is your standard deviation, S1, which is your standard deviation for the first sample. It will be this one, the 10 point something. Again, no rounding, you have to use all the decimals. And then the question also provide you the second one. So you have to use those. So you do the N2, which is 11. X2 bar is 87.753. And your S2 in this case is 9.946. And what you need to do here is enter all this into your StatCrunch. So you go to your stats, T-stats, to sample with summary, because we got the summary here. And then you enter all this in there. So 11. 89.727273. Oops, sorry, that is wrong. Sample mean 89.727273. That is the wrong one. This one is 10.169473. Sample size is 11. So this is for this. And then the N2 is from here. Standard deviation is 87.753. Sample mean is 87.753. Standard deviation is 9.946. And the sample size is 11. And I think if you look at your original, we are testing for greater than. So we will use the greater than symbol here. And we will compute. So the test statistic and the p-value is given here. So Savannah, you got us, Savannah. Taiwan, you know how to do the rest of it?
Yeah, thank you.
Yep. So make sure you guys, if a question provide you partially like this, that means you only get this. So make sure you run through the StatCrunch for finding all this information, and then you just put it in there. Anyone have any questions with this, number 8? So this is 0.325. Yep, and the rest you guys it's gonna be the same, So make sure you guys know how to do this question. Anyone, any more questions for me in 9.2, which is due on Wednesday, beside number 8? Anyone? Okay. So we will talk about 9.3. So we talked on last Wednesday, we talked about the notations that we have, the requirements. When we interpret this way. We are 90% or 95% confident that the interval from this to this contain the true value of the mean difference of, so on. So this is how we interpret the confidence interval. Okay. So when you guys do the interpretation of the confidence interval, we do not use the 9.1 and 9.2 that you guys learned in this section, where both of these are positive, then mu1 is greater than mu2, or both of them are negative, mu1 is, so we don't use that interpretation. So majority of the interpretation of this mu d is we are still using the old interpretation that you learned in chapter 7. Okay. When you do the StatCrunch, you do the stat t-stats pair. So that will be, if you go to StatCrunch, we will look at stat, t-stats, and pair. So this is the one that we will use in this in this section here. So the results when you do your hypothesis testing is you got this mean, this t-stats, and this p-value. So this mean is actually your D bar. Okay. So in this case, let's say you got this, your D bar in this case is actually the negative 11.6. Okay. Same thing. This is a test statistic. So the one that I highlight in yellow is the one that you need to concentrate on. D bar is this, the test statistic is negative 2.647 and the p-value is 0.013. However, this question, if a question is asking us to find SD, so which is the standard deviation here, you actually have to do your statistic again. You have to do in your StatCrunch. So it's not this. A lot of people think, oh, this is my standard deviation, 4.38. No. In order for you to find the standard deviation, you have to go to your statistics here. Like what we just did just now on this data set. You have to go to stat, summary stats, and column. Okay, so you have to go to stats, summary stats, and then you have to do columns, and you have to do the difference. Okay, so when you so that is, I will show you how to do that. So so make sure you guys know that in order for you to find the standard deviation, you have to go through this work. But if the question is asking us to find the D bar, which is the mean, it's gonna be in here, and the t-stats is your test statistics, and this is your p-value. And this is a very important hint. If you want to find the difference here, make sure you always take the first row minus the second row. So if you give you like this kind of questions, that means you have always take the first row minus the second row. Okay, so this is always the hint here. So make sure you guys do that, because if you did not do this, if you switch them around, you take the second row minus the first row, you will get everything wrong. Okay, so this is very, very important. So that I'm just going to highlight this so you guys can see this. So the difference is always first row minus the second row. Okay, I will show you how to redo this kind of questions. So in question 1, they give us this old and new rating for the highway fuel consumptions based on 5 different cars. So you need to find what is D bar and SD and what is mu D represent. So if you do this in your online homework, you can just click on and import to StatCrunch like what I just did early on in question 8. But unfortunately for this question, you have to type this in. So go open up your StatCrunch. I'm going to clear all this. Okay. And I'm going to type in, this is your old and this is your new. Okay. So you do need to type in these numbers in there. So this is very similar to your test. If I didn't call you guys to import it from your textbook data, if I give you data like this, you actually have to type them. Okay. Make sure you don't make any mistakes here. Okay. So in order for us to find the difference, okay, the D, the difference in this case is always taking the first minus the second. So you just type in here, sorry. On this, you just type in O minus new. Oh, they don't give it to you. Huh. Let me see. Give me a sec. I thought when they do that, they will give it to you. No, they don't. They usually do that, but now they don't. So what you do here, class, is you just run through the statistics. So yep. So go to stats, go to t-stats, go to pair. Okay. So go to stats, t-stats, and pair. The first column is O. The second column is new. So the O is the first, the new is the second. And then make sure you save the difference. Okay, save the difference because they will do the difference here. And you hit compute. We don't do the hypothesis testing, so you don't care about this. So you compute. Oh, they don't have the difference. They usually, let me do it again, sorry. Oh, there you go, it's over here. Sorry, it's over here, the difference. So these are your difference. So what they do is they just take the O, 16 minus 15, you get 1, and then 18 minus 16, you get 2. So they just minus this and they give you the difference. So again, let me show you how we get this. You go to t-test, pair, and then again, you go to, first is your O, and then new, and then make sure you click on the differences because, and then you compute, then a new differences will come out in this row. Okay, so you will look something like this. And once you get into, oh, I got another one. Let me get rid of that one. So I did twice. So what you do now with these differences, you want to find the mean, you go to stat, you go to summary stats, and you go to columns. And we are only doing the difference in this case. Okay. So it's a combination of chapter 9 and chapter 3 that you guys learned before. So your mean difference, or your D bar in this case, is 2.4. And your standard deviation in this case is 1.14. So this is how you find your mean and your standard deviation. So the D bar in this case is 2.4 from your StatCrunch, from these results. And your standard deviation, or SD in this case, is 1.1. We do have units because all these units is in miles per gallon. So your unit in this case will be miles per gallon. The question also asking us what is mu D represent. If you remember do you guys remember what I put down as a mu D here on Wednesday class? This is the
population mean difference between A and B.
Between what?
A and B, whatever A is and whatever B is.
Yep. So in this case, we're gonna use the same thing. So what is the mu D here? Is the population mean difference between, now we don't use A and B here because our A in this case is O rating. So between O rating and mu rating. Okay, so your A in this case is O rating and your B in this case is mu rating. So this is your so this is what is mu D. So make sure you guys know how to find the D bar and SD using your StatCrunch. Okay. You need to get the difference first, and this difference is what we're looking for. Questions on this one? Question 1B is asking us if the values are changed from miles per gallon, because this is miles per gallon, right, to kilometers per liter. So we are changing the units from miles per gallon to kilometers per liter. How do the test statistic affected, and how is the confidence interval affected? So let's take a look at the test statistics so you guys can see what's going on. So we do it, so then it's always the same. Okay, so we do the same thing, the O and the new, and then we do the test statistic in this case. So we just make it mu D equals and mu D not equals. And the test statistic in this case is 4.706, right? So I just write it down somewhere here so that I can remind myself. So the test statistic in this case is 4 point something, 4.706, 4.7067, something like that. I just put it down here. So now I'm gonna convert all this to kilometer per liter because conversion. So let me see how we convert here because I do not know. It's kind of a little bit difficult. So we just let's see, convert miles per gallon to kilometer per liter. There you go. So 1 miles per gallon is that. So I'm going to convert all my I'm just showing to you what happens so you guys see what is going on here. So next time you do not need to. So I got 16 here. So I'm going to put 16. So this is 6.8. So yep, this is quite a bit of work, but so this is, so I'm going to go with the old 2 with the new 2 because I'm converting. So this is 6.8. This is also 6.8 because they are 16 each. Next one is 18. 18 is 7.7. Lots of windows. So yeah, it's a lot of work, but you will see what's going on here. Next one is 27. So I'm going to convert 27. That is 11.48. 17, 7.2. Yes, class, you do not need to do this. I'm just doing that for you. So that's a trick behind it. 33 is 14.03. So now we go on to the new one. So 15. 15 is 6.38. 6.38. Minimize these two so I can just do this. We got another 15 here, which is 6.38. We got 24, 10.2. And then we got 29, the last one, 12.33. So now what I did here is I just convert all my all my miles per gallon to become kilometer per liter. And now I go to stat and I go to T-stats and I do the pair, same thing. And now I do old 2 and new 2 because that's the conversion. I don't need to find a difference. I just compute it. What do you notice about your test statistic is my test statistic used to be 4.706. This is 4.71. So it's actually quite similar here. And the reason why this is quite similar, this is 4.71, this is 4. It's a little bit off. It's not exactly the same. It's because when I do the conversion, I did not use all the decimals here, right? I just round to 2 decimal place. So you got that little error. So what can you tell me that when you convert your units from miles per gallon to kilometer per liter, your test statistic does not affect. It's not affected if we convert to different units. Okay, so this is a very important class. So if I change this to, from one unit to another unit, just do the conversion rate, your test statistic does not affect it by it. Okay, what happens to the confidence interval? So let's take a look at your confidence interval now. So last time is this. So I'm going to do the confidence interval. So I go to stats again, T-stats with pair. Again, I'm going to do the old and the new one. So I do let's say we do a 95% confidence interval. So this confidence interval is given us by this number. So I'm going to write that down again. So it is going to be between 0.984 to 3.816. Okay. And so that is a confidence interval. And now I'm going to change this confidence interval with the one that I use the conversion. Okay. And I still use a 95% confidence. Now I just use O2 and nu2. When you convert this, yes, your confidence interval will change, become 0.421. So this is using the miles per gallon. This is using kilometer per liter. Okay, 421, and this is 1.627. Yes, it is changed. But how does it change? If you type in the miles per gallon, so if you convert this miles per gallon 0.9 something, so if you convert this 0.98 something, it will change into 984. It will change into 0.12. So see that is a conversion change. Okay, and if you type 3.816, you will get 1.622. This is also conversion. So what happens to your confidence interval? Your confidence interval will change based on the conversion that we have in this case. Okay, so this is again very important. Your test statistics does not affect. However, your confidence interval will affect based on the conversion. Okay, so as you know that you have this conversion here. So this is not just happening for this section 9.3. This happens in all statistic class that you learn. Okay, so what do I mean is back in chapter 7, back in chapter 8, when we do this, right? We do this all in grams, right? So what happens if I change all this gram to become ounces or pounds or to another units? Your test statistic remains the same, 32.77, but your confidence interval will change the gram to become pounds based on the conversion. I don't know what is the conversion from gram to pounds, but it will change based on that conversion. So this is always that way, okay, in all chapters, in all statistics. So this just to point out to you guys that so when you guys change from one unit to another unit, your test statistics will not change at all. Okay. Anyone have any questions with this? In part C, they're asking for, we got two types of confidence interval. So when you find a 95% confidence interval, you get 1 miles per gallon. It's all miles per gallon. It's less than MUDI 3.8 miles using the sample data above. But if you treat this as an independent sample, you will get these two answers. Okay. For the 95% confidence interval. So what is the difference interpretation between those two? So what you guys know is, if you remember last time, I just get 0.98 to 3.8. So that's why I got this, this answer for him. But when I treat this as an independent, so this is where a lot of students do wrong in my test is they will treat this as independent. So that means they don't do this as a pair, but you do it as a 2 sample, like what you did in 9.2. You select this is old and you select this is new, and we do a 95%. And when you compute this, this is what you get, a negative 7.8 and 12.6. This is what you get for your confidence interval in this case. But the question is, why these two give us different things? Right? They are different, right? So what is the difference between this interpretation? So let's talk about the first one, the one that using 1 is less than MUDI is less than 3.8. So what is the interpretation for this is? Okay, the interpretation for this means that we are 95% confident that the interval from 1 miles per gallon to 3.8 miles per gallon will capture the true value of the mean difference, the population mean difference, sorry, because the mu-d means population, like what we just did on here, the population mean difference between the O and the mu rating. So this is how we interpret this confidence interval, the one we use the mu-d. Okay. How we interpret with the one that if you treat it as independent, the one that say negative 7.8 miles per gallon with the mu1 minus mu2 is 12.6. The interpretation for this is very different. Okay, so how do we interpret this type of confidence interval is you refer back to your 9.2 or 9.1. Does it capture, so if you look at this, you asking yourself is, are they both negative? Are they both positive? Are they one negative and one positive? By looking at the confidence interval that we have, we know one of them is negative and one of them is positive. So that means that it includes 0, then you conclude mu1 equals to mu2, right? So this is what you write as the confidence interval for that case. So I just want to point out to you guys that, so be careful with this because, I'm sorry. The interpretation for this is very different from the interpretation of the mu-d. So since the confidence interval is one negative and one positive, so it is capturing 0. It captures zeros. So mu1 is equals to mu2. So this is, yes, Casey.
So in other words, when it comes to it being independent, then we have to refer back to the 9.2.
No, independent.
Yeah,
So
when
this
it's
is-
independent. When
Yep.
it's independent, we refer back to for the
9.2.
interpretation. Okay.
Yep. So when it's an independent, you have to refer back to 9.2. You're correct. Yep. When this is a dependent case, then you have to refer back to chapter 7. Remember, we do VR 95% confident back in chapter 7. Okay. So so make sure you guys know that which way is the correct way to so in the test, which one is correct? This one is correct. Okay, this one is wrong. Okay, so make sure you guys know that this is wrong. So don't interpret it that way in your test, because don't write mu1 minus, because this is actually a dependent case. Okay, so that's why. So what I want to point out to you that the interpretation for these two are very different, and you just need to watch out carefully. Are we doing 9.3 or are we doing 9.2? So if you are doing 9.3, this is the way for you to interpret. If you are doing 9.2, this is the way that you interpret. Anyone have any questions here?
Yeah, I just got really lost. So if we're just looking at that problem itself, where it's asking about the independence, the independent sample and what the difference is,
Mm-hmm.
you're telling me that the first answer is correct.
Yes.
But then you said if it's independent interpretation, then we're supposed to refer
second.
back. Yeah.
Yep. But this question is, if you look at this, this is actually is dependent.
Yeah,
So you cannot interpret using this way.
but in here, it's saying if we treat the same
I
data
know.
as independent.
I know this. I'm
Oh,
just showing you here, Casey, is in the test.
Yeah,
Some people treat this as an independent samples, and they will do this way. Some people treat this as an independent sample, and they do this way, and the whole thing is going to be wrong. You know what I'm
but
saying
isn't
here, Casey?
but isn't the question asking us to treat it as an independent
Yes.
sample?
I'm telling you that, Casey. Okay, listen carefully. This is your this is how we interpret the interpretation is correct. Okay, both interpretation is correct, but in the test you cannot do both of this, right?
Yeah.
Either you treat it as dependent or
Oh,
independent, right? You cannot, in the test you can either have one or the other. So you have to pick one of this, and so I just want to point out to you that this is treated as dependent. So in your test, you should write this way, not this way.
Okay, I think
Yeah.
I just, okay.
Yeah. Just want to point out to you guys, because I graded I've been teaching this so much, and guess what happens is people treat 9.3 as 9.2 and 9.2 and 9 as 9.3. They got a big fat 0 in that test. Why? Because the way that they do is totally different like this. You guys got it now? So make sure you guys know this. This is very, very important. Okay. Let's take a look at question 2 here. So question 2 and 3 is asking, assuming that the pair samples are simple random sample and the difference has a distribution that's approximate normal. Again, this means that you do not need to check the requirements. That means the requirements is fulfilled here. Let's put down requirements is fulfilled. So in the test, if you see me writing this, assuming that this comes from a simple data pairs and this, that means the requirements are fulfilled. Okay. So this is talking about asking if the self-reported heights and the measure heights for males between age 12 and 16 are given us, and the units are in inches, or measurements are inches. So this is your unit, and this is a result. So what happened, class, is that I asked you guys, how tall are you? And let's say Anna says she is 68 inches tall, let's say. But then I say, why don't I measure you? So I just call her to go into that, you know, the device that measure how tall people is, and the result came out 67.9. And then I asked Nafisat, she is 70 inches tall, and then I asked how tall she is. She says 71 inches, and then I measure her, and she is 69.9 inches. And I do this for this many people, this many students. I want to figure out that if people who telling me is telling me the correct height, because you doesn't know, right? Sometimes people can tell me different story, right? Oh, I'm actually this tall, but actually, you know, you are either taller or shorter. Usually shorter, you don't tell me you're taller. So this is what the results got. So this is actually is a pair. This is a dependent work here, because one person is giving me 2 answers. Okay, so usually depend means one person give me 2, either before, after, or this case report and measure. So so you need to, this is a test, this is you need to perform a significant test level of you need to do a testing here, and this is your claim that there is no difference between this. Okay, so there are no difference. Again, the word no difference means equal. Okay, so no difference means equal. I just put it down there. So mostly we use the word equal or the word no difference. So make sure you guys know no difference is equal. So we have to go through the whole 7 steps of hypothesis testing. The good news is the requirement is already checked because of that. So the second one is you have to write the hypothesis statements. Oh, by the way, how do we write your hypothesis statements in this case? I didn't bring it up. So in order for you to write your hypothesis statements, we don't use mu1 equals to mu2 or mu1 is less than, so we use mu d. So in this case, mu d is the null hypothesis, mu d in this case is equals to 0. And your alternative hypothesis in this case is mu d is either less than, greater than, or not equal to 0. So this is it's very different from the hypothesis that you did in 9.2, where you use mu1 equals to mu2, and mu1 is less than, greater than, not equals to mu2. So this one is mu d equals to 0, mu d is equal, less than, greater than, not equals to 0. So again, very, very special here. Okay. So so we're gonna write this. So so your H0 in this case will be, I hit this. H0 in this case is mu d is always equal to 0. And your H1 in this case is mu d, because you want to be no difference. No difference will be not equal to 0. Okay. So you use that symbol not equal to 0. So this is your hypothesis statements. Next, we do the sampling distribution. Again, class, no matter, this is also talking about mean. So so the sampling distribution for this case is also t. So don't forget 9.3 and 9.2, they are all talking about mean. So that's why your sampling distribution is all t. You see everything here is t. So we're gonna use a t in this case for your sampling distribution. Next, we will find your test statistic here. And then we will find your p-value. So it's the same. So for this case, you have to enter these numbers into your StatCrunch. If you do it in your online homework, you can just export it into StatCrunch. So I'm going to start with the new one. There you go. Got a new data set here. So I'm going to put this as report. And this is measure. And again, class, in your test, because you cannot import this into StatCrunch, you actually literally have to type this one out. Okay. So I'm going to type this all out. 68, 71, 63, 70, 71, 60, 65, 64, 54, 63, 12 students. And again, be careful what you type in, because one wrong numbers, everything is wrong. $74.2, 65, and 7.8. Okay, so this is so what we do here is we have to do the difference. So we go to stat, you go to t-stats, you do the pair. The first one is reported, measure. So always the first row is always the first sample. The measure is always the second one. Make sure you find, if you want to find the difference, you go ahead and click on the difference. We are doing mu d equals to 0 and mu d is not equals to 0 because you're doing no difference, and we will compute. So your test statistic in this case is given us by -0.984, and your p-value in this case is 0.346. Okay, and we do the same decision and the same conclusion. So decision and conclusion is the same. We cannot run away from that. So our alpha is 0.01. So can someone tell me what kind of decision do we have here? Do we reject or fail to reject H naught? P-value in this case is what? It's less than or greater than alpha?
It's greater, so then that means.
That means we what?
We fail to reject.
We fail to reject H naught. So do not forget to give me the H0 because
Okay.
I will take points off.
Okay.
Okay. And what is your conclusion here? Since you fail to reject H naught, there is or there is not sufficient evidence. So this will be there is not sufficient evidence to, because when you fail to reject, it's always that it's not to support or to warrant rejection. Which one do you use here?
To warrant rejection.
And why we use warrant rejection in this case, Lawrence?
Because we fail to reject.
Not because you fail to reject.
Are you sure? Because I thought it, oh wait, it does not.
Why
It
is
does
warrant
keep it
rejection?
equal.
Yes, because your claim has equal sign. So do not forget, your claim has equal sign. So that's the reason why we use a warrant rejection. Yes, no difference means equals. Rejection of the claim that there is no difference in self-reported heights and measure heights. Okay, so that is your claim statement. Just copy and paste. So this is how we do this. There's no question. So this is how we do the 7 steps of hypothesis testing. Okay. Question B, the question B want us to construct a 99% confidence interval. So in order for us to construct a 99%, you just go to your option, go to edit. So now instead of doing hypothesis, you go to confidence interval. And the question is calling us to find a 99%. If a question did not do a 99%, you still use back the same trick that I teach you in chapter 9 here. Remember, if you have a one-sided, you do 1 minus 2 alpha. If it's a two-sided, if it's 1 minus alpha. So this is still applied to this, to the whole chapter 9 here. So that means since this is a two-sided test, because we're doing equal to, so your confidence level in this case is 1 minus alpha. And if you look at your 9.3 here, 1 minus alpha in this case is 0.01. So so that will become 99%. So 1 minus, so your confidence level in this case is 1 minus alpha, because it is a one-tailed test, two-tailed test. And we know alpha in this case is 0.01 in part A. So that's why this is still 99. So if the question did not provide us the confidence, the confidence level, you still use back the same way that you just learned in chapter 9. Okay, so that remains the same. So if you compute it, so this is your confidence interval. So your confidence interval in this case, the 99% confidence interval is negative 4.16 to 2.16. Okay. So this is how you find the confidence interval, and the question wants us to interpret this. So how do you interpret this? Is we use back the same interpretation on 9.3, not 9.2. So this is how we're going to interpret. We are 99% confident. So this is the interpretation we're going to use. We are 99% confident that the interval from, I'm going to use a little bit shortcut here. Those numbers are negative 4.16 to 2.16. And again, if you scan, I take off points because of the unit. There you can always type in there. Your unit in this case is inches. Remember the trick I showed it to you in your midterm. You can also do that. Okay. The interval from this will capture the true value of the population mean difference between reported, the first one, reported, self-reported, yeah, kind of self-reported heights and measure heights. So this is how we interpret this. And then for part, they also ask comment on the implication of whether the confidence interval limits contain 0. So the question is asking, do this have contain 0? Yes. So in this case, yes, this confidence interval contains 0. When it contains 0, in this case, mu d is equals to 0. Okay, so that means that what is that telling us when I say mu d equals to 0? Means the difference between the reported and the measures are the same. Okay, no difference. Okay, so that means that there is no difference between reported and measured. That means people are telling the truth. So that means this male aged between 12 to 16, they are telling the truth because we found out that it does, and it also apply, it does contain 0 here. So it also applied to chapter 9 that these two have the same conclusion, same result or same conclusion. Remember in 9.1 and 9.2, I always say these two must always be the same conclusion, right? They have to be the same. So yes, these two will have the same conclusion. So the only difference about this 9.3 is how we interpret the confidence interval, but the rest of the work is almost the same. Okay. Anyone have any questions on this one? Anyone have any questions? It's very similar to 9.2, but we use a little bit different units and a different way to do our testing here. Now I want you guys to read question 3, and I want you to try question 3 here. Okay. You have to get the data set from the textbook called Oscar, and we are doing between actresses and actors. Okay. This is the age of those who win. So I want you guys to try question 3. It comes from your textbook, your notes from your data from textbook. Try to do question 3. So the first question is asking you to test a claim there is no difference between actress and actors when they win the Oscar. So you have to go through the whole thing, the requirement check, your statements, your sampling distribution, your test statistic, I'm going to short form as TS, and your p-value, PV, your decision, and your conclusion. And see what you guys do. You can fill it when in the test. Yeah. I want to see how many of you make the mistakes that a lot of students make in the test. Anyone know what to do on question 3A?
So number 1 is met already
Okay.
because it's from that stuff.
Yep.
And then number 2, well, I got HO equals UD equals 0.
Mm-hmm.
And then at H1, I got UD not equal 0.
Mm-hmm.
And
Yeah.
then I have T.
Mm-hmm.
And then 4, I have,
Well, you are
Negative.
quick. You read it 4 already.
yeah, but I don't know if it's correct. I got negative 5.18.
Let me see. How do you know that too? I need to get it from StatCrunch. So you need to go to the StatCrunch, right? The website.
Yeah. Yeah.
And go to the Oscar, right?
Yep.
There should be one called Oscar.
Yeah.
So much things coming out. StatCrunch, data set from your textbook, and Oscar will be the one.
Yeah.
So those are the numbers. So you go to stats, go to T-stats, go to
Pair.
pair.
Yep.
Mhm. The first one is always the first one, actresses.
Yeah.
And actors. If you do not know, you can also look at the wording. Actress come first, then actors. So that means that is first, that is second. It's always like that. If you want, you can find the differences. That's up to you. So so you do this, you compute. So what you say just now, Casey?
Mine is negative 5.18.
Yep,
for the
119.
pair.
Mhm.
Yeah,
Negative
and then
5.19.
the p-value is 0 plus.
Yep, 0 plus. That's good.
And then I know that you put alpha equals 0.05, so I did that. And then
Yep.
number 5, I put
Is it
p-value.
0.05?
Yeah,
Yep, it's 0.05. Okay.
so the p-value is less than alpha, so we reject HO.
Reject H, no, H0. Yep. That's good. Yeah, that's very good.
And then for 6, I put there is sufficient evidence to warrant rejection of the claim.
You are quick. There is sufficient evidence. This is what you guys have to do in my test. Yes. To what?
To warrant rejection of the claim.
Warrant rejection of the claim.
There is no difference in between the ages of actors and actresses when they win the Oscar.
Oh my God. Okay.
Sorry.
You are. Now I know what you mean. That is correct. Again, class, make sure that is very good, Casey. Wow, you take less than 10 minutes to do this. What is my claim here? You just copy the claim statement, right?
Yep. And then the unit is years old.
Thank you for
ages.
the unit. Years old. So if you scared, I take points off. Make sure you just put like this. The claim again. There is the claim that there is no different. Okay, no. No different in between of ages. You guys know what to do, right? I just put it down here. It's right over here. That is your claim statement underlined. You guys doing all right here. Casey's doing like a bullet train here, but that is good. Questions with this 3A? So now we need to find the 95% confidence interval. So how do we find this?
Yeah, that's the one I have an issue with.
So you have your result here, right?
Yep.
So you go to the option and you click edit.
Yep.
And you don't do the hypothesis testing anymore. You do your confidence interval. And the question is asking for what?
The 95%.
95. So it's 0.95.
Yep.
And you just hit compute.
Yep.
So that will be your answer here. So so the confidence interval is very easy. Only one step. You don't go through so many steps. So the 95% confidence interval in this case is negative 10.91 and negative 4.86 years old.
Okay. I feel like because it's so easy, it's like.
No, this is how we do it. Yeah, and do the question ask us to interpret this confidence interval? No, right? The question didn't ask anything about it, so this is the end of it.
Okay.
Okay, and if they ask you to interpret, then you just follow this. This is how we interpret, and then you're asking for if you catch. And if a question did not ask us anything, then you just leave it blank like that. So this is what you do. Questions? Really good, Casey.
Thank you.
I also taking attendance here, so go ahead and do the chat room. Okay. Now, I just want to point out to you guys that what Casey did here is correct if we have this assumption. You see this assumption? Okay. So I say for question 2 and question 3, these are the assumptions that we use, right? But what happens if I don't have this assumption? What happens? I don't have this assumption. Then what Casey did here is all wrong. So that's why this assumption makes it everything is correct. Yes, what she did here is everything correct. But if the assumptions, so I put a little note here, based on the assumption. based on the assumption given in the question. Okay. So everything is correct. Based on the assumption, everything here you did is correct. You get full points. Okay.
If the assumption wasn't there, then we have to follow the, either it's dependent, is that what it is?
Yes, it is. So what happens if the assumption is not there? It's not given. So this is actually an independent case. You with me here? Suli got it. I mean, Nafisa got it. Yep, sorry. Nafisa
Yeah.
got it.
Is that because the
You got
actor doesn't depend on actor?
Yes, because these two groups are completely completely independent. The actress and the actors are completely, these two groups are independent case. So if you look at your data, they are not, is this the same person? Sorry. Is this the same person? These are not the same person, right? Okay, these are not the same person. That's the reason why that, just want to point out to you guys that in the test, if I don't, usually you have to read it really carefully. So in the test, if I don't give you this assumption, what you guys did here is all going to be wrong because we are doing mu1 equals minus mu2 in this case.
So does that mean that we have, instead of doing that, we're going to have to refer back to 9.2?
Yes.
What we're doing
Yes.
in 9.2?
You are correct. So if there is no assumption, this is an independence case. This is actually 9.2. So make sure, so the first thing that usually I tell people here when you do this two mean is ask yourself, is this an independent case or is this a dependent case? Because
You have both independent and dependent.
no, you
on
cannot.
the test? No, I mean on the test.
Yes, hello, yes. Yes, that's definitely this in your test. Hello, is in your test. Yes, this will be in your test, but you have to read the question really carefully. Are they independent or are they dependent? And if you answer wrong, the whole thing is wrong. So let's do another example. Okay. Let's do one example. I got another example for you guys. I'm gonna stop sharing and I'll let you guys look at this example. This is what I give to my other classes. Give me a sec. That's all I need to. Sorry, give me a second. Sorry, I'm looking for the examples here. Okay. Now I can share it to you guys so you guys can see it. Where's my share? There you go. So this is a test here. Yeah, this is what the finals looks like. So you are referring to this family heights, which is the file name. Fathers and their first son. Use a 0.05 significant level to test the claim. There is no mean difference in heights between father and their first son. So this is the questions you get. This is very similar to your test. And make sure you read upstairs. Test the given claim. Identify the noun, the alternative, sample distribution, test statistic p-value, conclusion. Assuming all the requirements are met. So when you see this, means that, do you need to check your requirement here, class?
No.
No. So again, we can skip the requirements. So my question to you here is, if you start just bang, bang, bang on that, doing that whole thing, you need to watch out because you might get wrong. So the first thing when you guys see it, we got 2 samples. We are doing the mean. See the mean here? So you need to ask yourself, is this independent or is this dependent?
That should be independent.
Why you say this is independent?
Because I'm talking about dad and son. Oh, dad and son.
Yeah, father and son.
Oh, that should be.
Lawrence, you cut off.
That should be dependent.
Which one, indie or dependent?
Dependent.
Yes, this is the correct way to do this. So you have to follow 9.3. So this question, you have to do the mu-d. And a lot of students think it's independent. So this whole, if you do independent, you lose 9 points. You lose not 9 points. You will lose a few points. I think I will take 2 points. So I will still read through the whole thing. I will probably take 2 points off because you give me the wrong test. If everything is correct, what you do? Yep. Now I want you to read number 14 now. So you do the same thing. You do again, assuming all requirements are met, means you do not need to check the requirements. Now read this question. Okay. So this is also
independent.
This also talking about 2 population, and they also talking about the mean. Both of them, So the question is this independent or is this dependent?
This is dependent.
Why you say this is dependent?
You're talking about weight loss.
Weight loss of what? Read the question carefully.
This one's a little bit confusing because I would say it's independent because we're talking about males and females, but then when you talk about dependent, you're talking about weight loss before and after.
But do we have a before and after?
No, so we're just doing
No.
independent because it's male and female.
You are correct. So this is independent because we are doing male and female. Because male is this much, female is this much, right? They don't give you what? The before after weight.
Yeah, sorry.
So
Yeah.
this is independent. So when this question is 9.2. So when you write your hypothesis statements, it's going to be mu1 equals to mu2, and mu1 is say lower, right? So it's less than 2. So again, this is what you get in my test. So make sure you read the question really carefully about this, because if you pick the wrong one, I will automatically take some points off, and you still work on it. You still get, this is a lot of points here, right? Look at all the points. Okay. Now, some of you ask me, what is this StatCrunch is? If you look at this, they all have a StatCrunch next to it, right? Okay, so what is this StatCrunch next to it? Yep, you will see they all have a StatCrunch next to it. What is this StatCrunch next to it? This StatCrunch that I want you to write, how do you get it? So remember, you go to StatCrunch, you do what? Go to stats, tstat, and pair, right? Remember that one? So this is what you need to write in your test, that you have to write stat, tstats, and pair. So in your StatCrunch, in this case, you do stats. Like this one, you'll become stats, tstats, and then pair. So that means you have to tell me how do you run this? Because last time we used proportion stats, 1 or 2 samples, right? With data summary. And then we also do t-stats, 1 sample, 2 sample, also pair. So make sure you tell me which one you go to run through it. So this is what you put in your in your StatCrunch here. So in StatCrunch, in this case, you have to give it to me as stats. Where you go, t-test. This is pair because this is independent. This is dependent, sorry, because father and son is dependent. And then for this case, you have to go to stats, t-test, what is called this, 2 samples with data, with summary, because the question gives a summary, the mean and median. So this is what you need to type in, tell me where. So again, let me repeat, in your finals, I will ask for sampling distribution and also ask for StatCrunch. What do you put inside this StatCrunch is what the link that you go. So you go to stat, you go to which one you go, and then you pick which. So you're telling me like, if you go this way, you go proportion stat, 1 sample with summary or something else like that. So I will look at what you have. And then because I know that if you use the wrong one, everything is going to be wrong. Because I can tell you're doing independent or dependent. Because if you do independent, it's 2 sample. If it's dependent, it's pair. So I can tell by looking at your StatCrunch if you do it dependent or independent, because you know it's easy to tell what's going on. Okay. Questions you guys have? All right. So that's it for today. So make sure you guys read the question carefully for this. I would strongly suggest you to practice. And I really also don't want you to practice on your homework, because your online homework is, this all is 9.3. This is all 9.2. So you have the mindset of, oh, this is all independent. Oh, this is all dependent. So in the test, you don't have that choice because it's all been mixed up. So the best way for you to review for your finals here is go to your textbook. So you go to the e-text. You go to the chapter 9. So you go all the way to chapter 9. That is a review. At the end, there's a review exercise here. Let's go in chapter 9. Oh, sorry, chapter 9. And that is there should be a test at the end. Where is the test? Let me go to chapter 9. That should be a test at the end. Quizzes, take quizzes and tests. No, let's go into the ebooks. Let's do 9.4. I'm going to go to the very last bit, go to the e-text. So I'm going to go to the very last page, so of chapter 9 here, and they will give you the questions, and they're all mixed. So you doesn't know, are they independent, are they dependent, are they proportion, or you know, so on. So I'm going to move this to 9 to the very end. So at the end of chapter 9, we don't do 9.4, so that is one section you skip. So at the end of chapter 9, they will have chapter test review. Not this, should be a chapter 9. Yep, sorry, it's this one. My bad. So it'll be review exercise here. I would recommend you to try a few of this. This is found on page 462. Review exercise. Try do those, and don't forget 9.4 is there. So 9.4 is doing standard deviation. So if you see about standard deviation, you can skip it. So I would recommend you to try to do this, you know, and also don't do the cumulative. Cumulative means you start from chapter 1. So I don't want you to do the cumulative. Yes, I will ask you to try to do 462, this one. You know, try to do some questions and see what you do. And the good news is, if you see this little link here, a little arrow, you can click on it, and there's a video that will show you how to do this question. So if you need help, you click on that link on that side of the textbook. Where the heck is it? It's not very friendly, I can tell you that. Oh, there you go. So if you click that little link here, the little earth thingy here, they will give you the video how to do all this exercise. So if you are stuck, you know, I would recommend you to click on it and watch it. But recommend you don't do it your own first, And again, class, when you watch this, do you think they will use StatCrunch or do you think they will use the formulas?
We use the formulas.
They will use the formula. So, oh, they will, oh, some they use StatCrunch. Oh, so if you see they use StatCrunch, good. Okay. If they use StatCrunch, good. I didn't know. Oh, they use StatCrunch on this one. So if they use StatCrunch means it's good. If they use the formula, then please do the StatCrunch. You will still end up with the same answer. Okay. I was shocked they use StatCrunch here. I thought they use, I don't know what they use here.
Do you have the sheet you gave us for the first exam? Do you have something similar for a second exam?
Yeah. Oh, this also use StatCrunch. Yes, you will get a review for your finals.
So are you able to give us that early?
I think it's posted in D2L already. Let me check. I think so. If you go to D2L, I think it's posted there. Where was it? Go to your content. Go to your review test. Oh, it's not there. I will post it over here. Yep. Probably tomorrow. Yep. I'll post it. And then you get a copy of it on Wednesday because we don't have class on this Wednesday. So you get a copy on next Wednesday. But I'll post it over here. The review for your finals. Yep. Anyone have any questions for me before we end today's Zoom?